Hi viewers, this is Sri Ramlu. Before watching this video, please subscribe, like it, share it, and my channel is SS Space Physics. So today's topic is a change of entropy when ice changes into steam. Alright. So when ice changes into steam, then how does the entropy changes? That is here we have to calculate. For this, let m gram of ice, m gram means either 1 gram 2 grams like this, m gram of ice at T1 Kelvin changes into steam at T2 Kelvin. It is T2 Kelvin. Let L1 and L2 be the latent heats of fusion and vaporization respectively. Okay, so here what we have to do, we have to take 1 gram of ice and that is initially at a temperature T1, and when ice changes into steam, then temperature also changes, and let the final change in temperature is a T2 Kelvin like this, and a L1 L2 be the latent heat of fusion. What is the latent heat? Latent heat means, suppose 1 gram of substance is there, and if you want to change this, let it is in state solid state. If you want to change this is into liquid state, substance into liquid state. Okay, here how much I have taken? Just 1 gram. 1 gram of solid when it is changes into liquid and at a particular temperature or at a constant temperature, that is called latent heat of fusion. Okay, see once again, latent heat means amount of heat required to change 1 gram or 1 unit, 1 gram of solid into liquid is called latent heat of fusion. Okay, here 1 gram of solid, if you want to convert it into liquid, then how much amount of heat is required? That heat is called latent heat of fusion. Next, what is the latent heat of vaporization? It is also, for this what we have to take, liquid we have to take. How much? 1 gram. 1 gram of liquid, if you want to convert it into gas, then what is required? Heat is required. Okay, so that heat is called latent heat of vaporization. So let me define it. Amount of heat required to change 1 gram of liquid into gas at constant temperature is called latent heat of vaporization. So you should not forget these two processes takes place at constant temperatures only, but in both process we have taken 1 gram. It is important. If you are not mentioning 1 gram, if you mention is certain, then we cannot say it is the latent heat of fusion. We say it is melting point. Okay, and for this boiling point we call. So if you mention 1 gram, then it is not melting and not boiling, it is a latent heat. Okay friends, that is the difference between latent heat and a boiling point and a melting point. Now, and it has a formula, latent heat formula. What is that? L is equals to Q by M. Okay friends, Q by M. So this is the formula, or sometime we write Q is equals to ml also. Okay, so from the above equation, from this equation we can write Q is equals to ml, or L is equals to Q by M. Sometime it is a, suppose heat energy is small, then write it is a dq, nothing will happen. Okay, see here. First of all, mg gram of ice, mg gram of ice at T1 Kelvin changes into at T1 Kelvin only. What? It is also T1 and it is also T1. What is the use? What is the meaning? Is it wrong? No. Why? Because if I want to change into water, then its temperature never change. Okay friends, when total ice melts into liquid, then its temperature cannot be changed. So that is why whatever temperature here present, same temperature I have written here. Okay, so temperature shows always 0 Celsius only, but whole ice pieces are converted into liquid without changing temperature. So that is why we call it is a fusion. So there is no change in temperature. The entropy change, the change in entropy is given as. So what is this? It is C. Entropy formula is what? Entropy formula is what? ds is equals to what? D cube by t. We write d cube by t. ds is equals to d cube by t. It is entropy formula. But here I didn't write it like this. It is ml1 by t is written. What is the difference here? So latent heat formula is used. Latent heat formula is what? L is equals to, I told you, q by m. I told you just now, q by m. Okay, but it is not big in quantity. He took only small quantity, that is dq, and he took a mass m only, but this L as L1, it is for fusion. Okay, from this dq is equals to what? ml1. dq is equals to ml1 only he took. So that is why in the place of dq means in this place ml1 this is taken, and temperature is what? Here to here same temperature, so that is why it is T1 is taken. So that is why finally we got this one, ml1 by T1. Okay friends, how it comes by like this, dq is equals to ml1. So here ml1 is substituted. It is first one. Next, second one, and let it is a delta S1. So ds can be sometime written as delta also for small, very small quantity. If you want to mention the entropy small quantity, then we have to write a d instead of d, delta also. And next, secondly, mg gram of water. So now see, the whole heat ice is converted into water. Now we have to take water. Now mg gram of water at a T1 Kelvin. Here see, at T1 Kelvin. T1 Kelvin is changes into T2 Kelvin. So suppose water is there. If you heat it, temperature what happens? Increases from 0, 2, 3, 4, 5, 6, 7, 8, 9, 20, 30, 40, 60, 70, 80, 90, 91, 92, 93, 97, 99, till 99 its temperature. Okay, so like this temperature changes from 0 to 99. So see, the values are different changes. 0 is T1 is taken, and 99 to almost to 100 it reaches. So at 100 is, let me take it as T2. So like this so it present water present not only from 0 to 100, up to 100 it present. So different values are there. So that is where T1 and T2 is taken. For this we should not use latent heat formula. For this we have to use specific heat formula. That specific heat formula is this one. Okay friends, specific heat formula we should use. So before that what it is, what? Entropy formula only. Entropy is what? dq by dt. Okay, just now I told you in the previous video, I told you dq is equals ds is equals to dq by t. It is a second law of thermodynamics. Okay, it is second law of thermodynamics. dq is equals to ds is equals to dq by t, and in the place of q, we have to substitute the value from here. So see, it is the actual formula of specific heat. Specific heat formula C is equals to 1 by m dq by dt. From this dq we write, bring this to this side, cm dt, mc dt. So like this, mc dt we get from this formula. In the place of dq substituted. So this dq we have substituted here. And a temperature, so here T1 and T2, two different temperatures are there. When the two different temperatures present, specific heat we have to use. When there is no change in temperature, latent heat formula we have to use in the place of dq. Okay, so here in the place of dq specific heat is substituted, in the place of dq it is here latent heat is substituted. That is the major difference. And mc both are constant, take it outside, and its integration, see its differentiation is presenting above, so then we write it is log. Okay, log, and integrating, if you integrate you can get like this finally only. Here also you can get log t1 minus log t2, and if you apply log a minus log b, then log a by b you get. So finally we get this formula. mcdt. So now it is in terms of base e only. If you want to convert it into base 10, so that is see the relation between the base e and base 10. So conversion from base e to base 10 is a 2.3026 lakh 10. That is a conversion. Finally, next, so it is a first, second and third one. It is a final one. Why? Because water has three states, so that is why it is a first state ice, second state liquid, third state is steam or gas. Finally, mg gram of water T2 Kelvin changes into steam at a T2. Suppose water present at 100 degrees Celsius. So whole water may be converted into gas only without changing 100 value. It shows 100 value only. Okay. So at 100 degrees Celsius, whole water converted into what? Steam only without changing temperature. So here temperature is not changing means we have to use such a formula. Okay. Latent heat formula we have to use. So what is that? First entropy is equals to dq by, it is T. But in the place of dq, what you have to substitute? In the place of dq, ml1 you have to substitute. So it is our ml we have to substitute. But for what? Evaporation it is L2. For fusion L1. So for ice L1, for steam L2. So like this it is substituted here, ml2 by T2. Now what we have to do? Total thing, three quantities we have to add. This one and this one, this one. If we add these three things, then how the entropy changes of water when it is ice, if it changes into steam. Now see here, the total change in entropy when ice is converted into steam. So delta S is equals to delta S1 plus delta S2 plus delta S3. It is a delta S1 formula, it is a delta S2 formula, it is delta S3 formula. So like this it is a total entropy of ice changes into steam. Okay friends, thank you. Don't forget this subscribing my video till the end. Thank you.